So last class, whenever we saw an x squared, we made something equal to 0 so we could factor it, right? In today's class, we're going to look at questions where there is a squared, an x squared again, but there's no additional stuff like an x. Can you see in the first one we have an x squared, but there's no plus 5x or minus 3x, the x squared. In the cases where you just have an x being squared, if you can get that x squared by itself, so we're going to isolate that x squared, because if you can do that, then you can square root both sides. Unlike radical equations, if you do your math correct, you will get the right answer. You won't get any wrong answers. There will be no extraneous roots. So we could do this just for fun, just to make sure that we got it right. But for these ones, verifying is not a necessity, unlike radical equations where sometimes you would get an answer that didn't work. So just to save time, we're just going to solve them. You don't have to verify. Not bad on a test to verify it just to make sure you know you got it right or wrong. But for quadratic equations, when you solve them, your answers will either be right or you made a mistake somewhere else and they're wrong. But it's not like you'll do all the right work and one of your answers will be an extraneous root. So we need to isolate x squared and then square root both sides. So in this first one, do we have just some x being squared? Yes. I can add 7 to both sides. That would give me 3x squared equals 15. I can divide both sides by 3, and I would get x squared equals 5. So we've isolated the x squared. We can now square root both sides. And we get x is equal to plus or minus root 5. Maybe you want to put a little note here. To remember plus or minus. You would only get half the answer, because there's two answers. One is plus root 5 and one is minus root 5. So you get half. Sometimes in some questions, if it's a 2-mark question, you only get one of the 2 marks because you've only got half the answer. Sometimes if it's the last step, it's only a half-mark deduction. But yeah, there are 2 answers, and you only got one of them. For B, this is like writing both of them. Or you could, if you wanted to, you could write root 5 or negative root 5 like that and write them separate. It is easier just to put the plus or minus. But that does mean that there's 2 answers. So for B, we've got an x being squared. You can see that it's built into it right there. The thing that is squared is already isolated. Can you see that what's being squared is already by itself? Outside of what's being squared, we have no other x's. There's not 20 plus 3x or any other x's in this. So this is one where we can isolate the x squared, which it is already, and then square root both sides. When I square root both of these sides, here I'm going to be left with just x plus 3. And here I'm going to be left with plus or minus root 20. If I wanted to get x by itself, I'd have to subtract 3 on both sides. So that's going to give me, and generally speaking, when we have a radical in an equation, because I could put the minus 3 here, I could put it here, or I could put it at the front, right? That wouldn't make a difference in what the equation's equal to, Because if you start with a minus 3 and add something or subtract 3 at the end, it doesn't make a difference. Generally, when we have a radical, because some of you get a little bit overexcited with radicals and some of you just don't realize you just keep extending that line, sometimes I'm confused when I'm marking it, and sometimes even students are confused while they're doing the work. Oh, is that minus 3 inside the square root or is it not? Should I make it root 17? So we always put the minus 3 or whatever number we're adding and subtracting on both sides in front so you don't get tempted to make root 20 minus 3 into root 17. Because you can't put those together because they're not like radicals. Going back to our radical unit, is this answer simplified? Not yet. How can I simplify root 20? To 2 root 5. And that would be our final answer. Questions for this one are question number 4.